So in this video, we're going to see problem from exercise 8.2, which belongs to chapter number 8, quadrilaterals, and we're going to look at the problem number 5, which is from this figure 8.31. Okay, so let's read what the problem is. Let's try to zoom in a bit. Okay, so in a parallelogram ABCD, so this ABCD is a parallelogram. Okay, E and F are the midpoints of sides AB and CD respectively. Okay, so this is E, which is the midpoint of AB, and this is F, which is the midpoint of CD. So what is done is from this midpoint F, okay, they have drawn a okay, sorry. So they have drawn a line which goes to the vertex A, and from this midpoint E, they have drawn a line which goes to the vertex C. And then they have constructed this diagonal, which is BD, and it intersects BD at point P and point Q. Okay, so now what does it say? Show that the line segments AF and EC, okay, so this is our AF and this is our EC, trisect the diagonal BD. So the keyword is trisect. I'm just going to highlight it, this keyword trisect. Okay, trisect the diagonal BD. So this is our diagonal BD, which will get trisected by at points P and Q. Now what does trisection means? It's similar to bisection. Yes. So basically this DP, okay, DP is equal to PQ is equal to BQ. That is what is trisection. Okay, the line BD is divided into three equal parts and hence it is called as trisection. Okay, so the word tri, I'm just going to, this word tri means three. Okay, so in bisection, bi means two, so it divides, so a point will divide a line into two equal parts, so we say that the point bisects the line. But here the line BD is getting trisected at 2 points P and Q. So DP is equal to PQ is equal to BQ. So to put it in simpler words, we have to prove that DP is equal to PQ is equal to BQ. Once we prove that, we can very confidently say that this line BD is getting trisected at the points P and Q. Okay, so first let's mention that to prove. So in simple words, what we have to prove is dP is equal to PQ is equal to BQ. That is what we have to prove in this given problem. So once again, let's get rid of this highlighted things and even the other thing. Okay, now yes, so how do we approach this? This is our given figure A, B, C, D, E. Now let us focus on this quadrilateral AFCE. Okay, A AFCE. This is a quadrilateral. Okay, in this quadrilateral, now FC is parallel to AE. Why? Because DC is already parallel to AB. So FC will obviously be parallel to AE. So that is our point number one. So in quadrilateral AFCE, okay, FC is parallel to AE, okay, because they are already opposite sides of a bigger parallelogram ABCDE. Okay, so that is our first point A, and point number B is going to be, now F is the midpoint of DC, okay, which means DF is equal to FC, okay, and similarly, okay, E is the midpoint of AB, so AE is going to be equal to EB, and let me write it, this is going to be half of DC and this is also going to be half of AB. But this whole thing ABCDE is a bigger parallelogram, and so opposite sides of a parallelogram are always equal to each other. Okay, so I'm just going to write here. However, AB is equal to DC. Okay, why? Because they are opposite sides of parallelogram. So let's write here opposite sides. Okay, of parallelogram ABCD, okay, the bigger parallelogram ABCD. So AB is equal to DC, so half of AB will be equal to half of DC, which means these four segments are going to be equal to each other, okay, which means FC is going to be equal to AE. Okay, so that is our conclusion. Yeah, I'm just going to take it here. So the conclusion from this whole from this point number B is going to be AE is equal to FC. Okay, this is an important thing. AE is equal to FC. Now look at this. FC is parallel to AE and FC is also equal to AE. So let's come to this figure now. So this FC is parallel to AE and this FC is equal to AE. So if the opposite sides of a quadrilateral are equal to each other and parallel to each other, then the given quadrilateral is a parallelogram. Okay, so that is the important conclusion that we wanted to come at. So I am just going to draw a line here. Okay, thus, so let this be a point number 3. Thus, quadrilateral AFCE is a parallelogram. This is an important conclusion in our proof. Okay, so AFCE is a parallelogram because these two opposite sides were equal and parallel to each other. Now, if this is a parallelogram, now I'm going to erase this. If this is a parallelogram, then this line is parallel to this line. Okay, why? Because they are the opposite sides of a parallelogram. So FP is parallel to CQ. Okay, now we're going to need this figure. So what I'm going to do is just cover this so that, yes, so that we can use it to do our problem solving. Okay. Uh, Now focus on this. Yes, focus on this FP and CQ. They are parallel to each other. So that is the first point I'm going to write. Point number 1. FP is parallel to CQ. Okay, why? Because they are opposite sides. Okay, opposite sides of a parallelogram. Parallelogram. Which parallelogram are we talking about? AFCE. This parallelogram. Okay. Now, once again, let me erase this. Now, focus on this triangle DCQ. Okay. Consider this triangle DCQ. In triangle DCQ, F is sorry. In triangle DCQ, F is the midpoint of the line DC. Okay, and FP is parallel to CQ. Okay, so I'm just going to mention that point here. So point number 2, in triangle DCQ, okay, F is midpoint. F, because that is given. F is the midpoint of DC and FP is parallel to CQ. Okay, that is from here. F is parallel to CQ. Thus, by converse of midpoint theorem, in triangle, what can we say? That's yes. So from converse of midpoint theorem, what is the converse of midpoint theorem? So converse of midpoint theorem states that if you draw a line from a midpoint of a side parallel to the third side, then it will also touch the other side at its midpoint. So this line DQ, for this line DQ, P is the midpoint. Okay. So from the converse of midpoint theorem, we can say point P is midpoint. Point P is the midpoint of DQ. Okay. Which means, what does this mean? That is, so that is DP will be equal to QP. Okay, very important. DP is equal to QP. So that is one thing we wanted to prove here. Look at this. DP is equal to PQ. We have successfully proved the first thing. DP is equal to PQ. So instead of PQ, I have written a QP, but it's the same thing. So DP is equal to PQ is proven. Now we have to prove that PQ is equal to PQ. So again, the approach is very similar. Let's try to zoom in. Let's try to get rid of this. Now we consider this triangle. Okay, we consider this triangle to make our P is the midpoint of DQ. Now we have to consider this triangle. Yes. So consider triangle APB, this triangle. Okay. Now once again, in order to make our statements, I am going to cover this. Okay. Okay, done. So let's try to zoom in again. Okay. Yes. So point number one. Point number one. Consider the triangle. Okay. This is triangle that we will consider ABP. Okay. In this triangle ABP, let's zoom out a bit. Okay. In this triangle ABP, first thing is E is the midpoint. E is the midpoint of AB. Okay. And second thing is EQ is parallel to AB. AP. EQ is parallel to AP. Why? Because this is a parallelogram that we have already proved. So this is okay. AFCE is a parallelogram. So this is a bigger parallelogram. Okay. So these two sides, which are the opposite sides of parallelogram, will be parallel to each other. So let's come back here. So EQ is parallel to AP. So EQ is parallel to AP. E is the midpoint of AB. So this line that we construct and it touches PB at Q. So Q will be the midpoint of PB. Again, why? Using the converse of midpoint theorem. So I'm going to say so using converse of midpoint theorem, converse of midpoint theorem, we can say Q is the midpoint. Q is the midpoint of PB. Okay, that is when it's a midpoint. What does it mean? That means PQ is equal to BQ. Okay, PQ is equal to BQ, and that is what is the thing that we wanted to prove here. Okay, here it is. PQ is equal to BQ. So we have proven PQ is equal to BQ, and the previous step we proved that DP is equal to PQ, and thus we can successfully say that DP is equal to PQ is equal to BQ, which is what we wanted to prove. And this indirectly means that the line segments AF and EC trisect. They trisect the diagonal BD. So I'm going to erase this highlighted thing. Okay, and yes, this DP is equal to PQ is equal to BQ, which means these points P and Q have trisected this whole diagonal BD, and that is what this problem wanted us to prove. So to quickly revise, the way we started to approach this problem was, first of all we proved that this is a parallelogram. Okay, this quadrilateral is a parallelogram. Once we got that, we focused on this triangle. Okay, so this line is parallel to this. Then we focused on this triangle. Well, this line is parallel to this. So all we tried to prove is P is the midpoint of this and Q is the midpoint of BP. Once you prove that, then this statement follows from it.